sorry I had to go back. The last video really didn't, went over 15 minutes and I couldn't upload it, so I had to modify it. So let's start again on this. So it's going to be one of four of those. If I look at, that's kind of like the x value. And if b is positive, then I know the graph is going to be wrapped around the positive x-axis. It's like a heart shape, sort of speak. Not exactly like this, but something like that. Okay, I'll get it. Third time will be a charm. The catch is, you wouldn't know whether it looks like this or it has this loop. It's one of those two for sure. And if b is negative, if this number in front of the sort of the x value is negative, then this is the same shape but wrapped around the negative x-axis. So it's not exactly a heart, but like a heart. It could have a loop, it could not have a loop. We're not sure how to do that. And identically, r equal a plus b the sine of theta. Well, that will behave almost the same way. That is, either if, since this is again the y, so to speak, if this is positive, this is a heart shape right around the positive y-axis. And it could have a loop, it could not have a loop, we're not sure yet. It's one of the two. Or if b happens to be negative, it's a heart shape, and that's wrapped around the negative y-axis. And again, it could have a loop or not a loop. Not to worry if you're not really getting this loop business, because there's a really easy way of figuring that out, and I'm going to show you how that plays, not only for just those, for any graph. It turns out I can pick the graph of any of these shapes that I did up till now by simply graphing a sine wave or a cosine wave. A simple basic sine graph will do the trick. That's all I need. Or a cosine will do the trick. So if I was to look at y equal a, a cosine, my traditional cosine wave, just like we did in 1.5 and 1.6 and all of these, and a basic sine wave, pretty much if you could just catch the graph of those and label all the values that we labeled back in the days, that is, pi over 2, pi, 3 pi over 2, and 2 pi, and that is a 1 and a negative 1. And similarly here, that is a 1, that is a negative 1. This is the period, half. However, we labeled all of these awesome graphs. It turns out those two shapes give you pretty much everything that you need. That will include the loop, the non-loop, one of those, whatever you like, even those. So now we're going to practice some of these problems, actually tons of them. And we want to start graphing those. So 1 plus the sine of theta. We agreed that, you know what, this is the y positive. So this is either one of those or one of them. Now it's important to know that, because you could use symmetry. The right half of this graph is identical to the left half. It's the same, right? Symmetric with respect to the y-axis, so to speak. So this works at amplitude. The vertical shift is 1. Oh, I thought I fixed that one. I fixed all of them except that one. Here we go. So I start with a shift of 1, and I label that clearly. And I would move a unit above and a unit below, which is the amplitude. 1 unit above. If I am at 1 and I move 1 unit above, I am at 2, and 1 unit down, I am at r equals 0. And here's gonna be the main use of what we agreed in 4.1 that you're gonna master. I look at this graph. This graph starts at the origin. This is a new origin, runs up to the amplitude, back down to the starting point, and there it is. This would be 2 pi. This is pi. half of it, this is half, and 3 pi over 2. And let me show you how this graph goes. So remember the point graphing? That's what we're going to do. We're going to start with r and theta. Remember we said we agreed on, we're going to know what the points are. At theta equals 0, r equal 1. At theta equals 0, r equal 1, I'm like that. If r equal 1, I stay on this circle. If r is smaller than 1, I'm inside, and if r is bigger than 1, I'm outside. I notice that this increases. By the time I hit pi over 2, r will equal 2. There's pi over 2, and r equal 1, 2. There it is. That's expected. Now, I'll tell you a secret. This loop is generated if r changes from positive to negative or negative to positive. Meaning, if r is always positive, there's no loop, and if r is always negative, there's no loop. Now, when I glance at this graph, between pi over 2 and pi over 2 and pi, r is positive, but it's decreasing. By the time I hit pi, r would be a 1. Well, there's pi and there is 1. Decreasing, there it is. Now, r keeps on decreasing. By the time I hit 3 pi over 2, r equal 0. Between pi and 3 pi over 2, r is decreasing. By the time I hit 3 pi over 2, r equals 0. And since this graph is symmetric, I know what that last part looked like. And there it is. Now, you don't need directions for our class, but in some applications of physics, you need the direction. You could label that if needed. Again, you don't need to label that for our class. And there's the graph. So I can get all of these graphs by sketching a basic cosine or sine. If I get to the next problem, r equal 2 is a vertical shift. So I would move 1, 2. Then I would label that clearly. Amplitude is 2. I go up 2 units. If I started at 2 and I went up 2 units, I am at r equal 4. And if I went down 2 units, I am at r equal 0. A graph of a cosine starts with an amplitude, but this is upside down. So the graph looks like this. And normally, generally speaking, that generates everything that I need. This is 2 pi, this is pi, this is pi over 2, and this is 3 pi over 2. So let me start again, and let me start with the first piece. So I know this is a graph that's wrapped around the negative x-axis, right? And there's no loop because it's always positive. I start at 0, I am at 0, I am at the origin, increases. By the time I hit pi over 2, there's pi over 2. R equal 2. So I'm going to rescale this. I'm going to say this is 2 and this is 4. You know, for this graph, I really don't need those. Right? So R increases. By the time I reach pi over 2, I am at 2. Let's say that's 2. So there it is. And R keeps on increasing. By the time I hit pi, R will equal a 4. There's pi. And there's 2, there's 4. Keeps on increasing. Pretty much I'm done. I know what the graph looks like. It's identical. I could just mimic the rest, or I could practice some more. From pi to 3 pi over 2, R is decreasing. From pi to 3 pi over 2. By the time I hit 3 pi over 2, R equal a 2. There's my 2. And keeps on decreasing. By the time I hit 2 pi, R equals 0. There's 2 pi. And there's 0, this goes back to the starting point. And that's how all of these graphs look. Now, if I look at problem number 44, r equals 2. I would move a unit above it and a unit below it. A unit above it will be 3 and a unit below it will be 1. So this is an upside down cosine. And it looks just like this. And if I follow these points, this is still 2 pi, this is pi, pi over 2, 3 pi over 2. And if I trace the graph again, let's go. At 0, I am at 1. At 0, I am at 1. This increases. By the time I hit pi over 2, r equal to, there's pi over 2 and there's 2. And it keeps on increasing. By the time I hit pi, r equal 3, there's pi and there's 1, 2, 3. And I know this graph is symmetric. I know that the graph looks something like that. I could mimic the graph. I could continue it just for practice, something I should really do a lot. So between pi, it decreases until I reach 3 pi over 2. By the time I reach 3 pi over 2, r equals a 2. There's 3 pi over 2 and there's 2. And keeps on decreasing. By the time I hit 2 pi, I am back to 1. There's 2 pi and there's 1. And there it is. So the heart shape could look like a heart or inflated or, degraded. It could be depending on these numbers. We're not going to get into the cases because that doesn't matter. I can get all of these graphs just by looking at this. I have a few more to go, as you see. I want to do one more before I move on to the last video. R equal 4. Well, we're getting the hang of this hopefully. 1, 2, 3, 4. There's r equal 4. 2 units above and 2 units below. The only problem would be the phase shift here, and there is none. R equal 4, 2 units above is 6, and this is a 2. What I do, I rescale this, 2, 4, 6. Very simple to do. So if I start the graph, if I start with the graph of a sine, there it is. That's one full wave, or period, or cycle, whatever you want to call it. That's 2 pi. That is pi. That is pi over 2, and that is 3 pi over 2. And you will notice this first portion. At 0, I am at 4. At 0, I am at 4. Increases. By the time I hit pi over 2, I am at 6. There's pi over 2, and there's 2, 4, 6. And then decreases. By the time I hit pi, I'm back to 4. There's pi, and there's 4. And then keeps on decreasing. By the time I hit 3 pi over 2, I am at 2. There's 3 pi over 2, and there's 2. And of course, I know this graph looks something like that. So if I go for the last part, between 3 pi over 2 and 2 pi, by the time I hit 2 pi, I am at 4. There's 2 pi, and there's 4. And there's the graph. I'm going to stop this video here and continue the rest on the next.